like how other branches are also utilizing the remote sensing, uh, remote sensing and how it is utilized in disaster management. So, may I request everyone to mute their mic so that it will be easier for me? Yeah, I continue. So, talking about me, as Dr. Chakradhar Deka has briefly introduced to me, presently I am working with Purvanchal University, which is in Nepal, and this is in eastern part of Nepal, so more close to Assam. And we were established in 1995 as by the government of Nepal. It is a government undertaking university. So approximately we have now around 40,000 students who are spread throughout the country. And we have around 73 different degree programs from bachelor's to PhD. So we have PhD in the management faculty, which I am leading as a dean now. So it was my pleasure to invite the Vice Chancellor of Guwahati University to my university here at Purvanchal University on the occasion of convocation, on the 9th convocation that we had. So I feel honored for that. Now, why I am talking in this particular topic, basically, if I look into, I'll just go into that. Why I'm talking about remote sensing, why I'm talking about disaster management, how do I fit into this? This is very important for maybe for me to clear to my audience that how do I fit in? As Dr. Chakradhar Deka has explained or introduced me, that I have done in the area of management. I did my schooling from Guwahati. I did my college from Cotton College. Then I did my MBA from Guwahati University. So after that, I went on to do my MS in logistics management, and then my PhD also in the same area, in the supply chain management area. Now, how, because logistics is that area where I am much focused on, and in logistics we have a very important component called humanitarian logistics, and humanitarian logistics comes into when we have to manage the disaster. So that's what basically I fit into here. So I have worked a little bit in this area, and we have a lot of use of remote sensing. So today I will be trying to show the relationship of humanitarian logistics and how remote sensing is important component in it, and how does it provide us the valuable information which helps us in managing the disaster. So that's how I start. If you see natural disaster, if I say the two pictures that I have used here itself tells us a lot of story about it. Basically, natural disaster, if we can say that it's a kind of an act of nature, such a magnitude that it creates a situation where it disrupts the life of people. They are plunged into helplessness, they are suffering. So as a result, society need to provide them food, clothing, shelters, medical assistance, nursing assistance, or maybe some necessity of life like a place to live, provide food to them. So those things are needed. And this is how natural disaster has been defined by WHO. Now, one thing that I want to talk about, disaster does not come beating the drum. This is a very, very popular proverb that we use in Nepal, in the Nepali society, that which actually means that disaster do not come or does not take place by telling that I am going to take place. It happens all of a sudden. So this is what the characteristics of a disaster. Now, if you look into disaster in these days, what we see is that disaster, either it could be natural or it could be man-made, and it has become a major concern for society throughout the world. Then the frequency of this is also increasing, and the magnitude is also increasing. So this is something of concern for the society. So definitely, if you see this statistic that has taken from WHO, which says that around disaster itself kills around more than 90,000 people, and it affects around 160 million people worldwide. So this is something alarming. Definitely, disaster is something very, very alarming. Now, as I say, disaster could be a natural disaster or it could be a man-made disaster. So in natural disaster, which are basically meteorological, like flood, cyclone, hurricane, or thunderstorm, drought, cold waves. or geological like earthquake, volcanic eruption, landslide, tsunami, debris, or mud flows, which are very common in certain part of the world. Or we can have an environmental or biological like global warming, climate change, ozone depletion, solar flare, epidemic like what we are having facing right now. So these kind of things happens. Like whereas man-made disasters could be technological disasters like accidents, large accidents, or structure failures like explosion, fires. That we can look into, like the Chernobyl incidents, or industrial. It could be chemical spills, oil spills, radiation, poisoning of gas leaks. So like the recent the Beirut explosion that we had of the chemical storage. So those kind of things are what disaster. Or sometimes it could be created by warfare, which we see in the form of war, terrorism, internal conflicts, civil unrest like Darfur case, or the Syria case. We all know that that creates a lot of disaster in the society. So basically we can categorize in this. But then definitely when disasters happens, like if I say, this is basically just to remind you the earthquake that happened in Nepal in 2015. So this is a picture from there. You can see how devastated it was, and we know that we lost a lot of people, a lot of villages were destroyed, a lot of roads infrastructures were destroyed, and that creates a lot of problem, and people going to suffering, and we need to provide them shelter, we need to provide them food, we need to provide them places, or we need to rescue them from the strapped buildings. So this is very, very common, especially in this belt. As you know that Assam, also India's that portion, northeast portion, Nepal, and many other region of the world falls in the seismic zone. So we are prone to earthquake, and this happens very very often, and we see this kind of catastrophe now and then. And this is very common even in Assam. We have seen, I remember in 1950, 51, there was a very big earthquake there also. So those kind of the histories are there. This basically the major other kind of catastrophe that we see in that part of the world, like in Assam. And these are the picture from Assam and Guwahati. You see the flood that we see. That is also a major things. But the right hand side is in Guwahati somewhere, and this is somewhere in some village in Assam. So this flood, every year we have this particular flood. How do we manage this? Basically, this is something an important issue. If you look into the tsunami, and we all know in 2004 when the tsunami happened, and what kind of consequences it had in the whole of this region, basically the Southeast Asian region, the East Asia region. So that was affected badly. And these are the pictures from the tsunami during the tsunami that is coming in Japan. So that picture, we all know, I think we have all seen the videos of this happening. So we all know how severe it was. And I think disaster management became a very, very important things after this incident also. Now, natural disaster, we know happens, the one picture that shows. But what does it, what do we do with this then? What are we going to do with this? So definitely there has to be some answer for it. And definitely that answer is we have to respond and manage. That means we have to manage whatever the disaster happens, be it natural, be it man-made. We have to respond to it, we have to manage it. And there are a lot of things that goes in it actually. So that's where I'm trying to bring this topic here. I know many of you are learned in the area of remote sensing, so that may be a little bit so, but I'm trying to show one different perspective of remote sensing and how does it applies in our work. So that's what I'm going into. As I said, we have to respond and manage. And how do we do that? Basically, in disaster management, this basically approach is very well known, and I thought that I should start with from here also. And this is basically there are two parts. Pre-disaster and post-disaster. So there are two activities pre-disaster and the two activities post-disaster, which are, some people argue that it is not cyclic, these are not cyclic, but maybe there are some relation between this also. Like if the disaster happened, then definitely we have to take the response, emergency response and recovery we have to do, right? To provide timely relief to the survivors, or for the people who are injured in that. We need to provide them some kind of response. So this is something very, very important. Immediately at the time of the disaster, immediately after the disaster. But after that, even if you look into the next stage, like if you see Nepal, like in 2015, even now, many of the people are still finding difficult to make their own houses. And that is where the disaster management again comes in terms of rehabilitation, in terms of reconstruction. The whole village, the whole infrastructure, the whole system has to be developed so that the people can go back to their normal life as they were in before. So this is something very, very important. But then the other two that we have, that is the pre-disaster, that is preparedness. How can we prepare? How can we be prepared for any consequences that may happen because of certain risks? And that we know that we can look into maybe certain areas like landslide, or we can look into some kind of the flood coming up, where we get time to prepare, like a cyclone is coming, so we get a window of maybe 2 days to 3 days and hours. Within that time we have to prepare. So preparedness is one aspect of disaster management. And another one is how do we can, in the long term, how can we prevent this kind of disaster, or this, and how we can eliminate this possibility of this disaster. So definitely these are the major 4 areas of response that we take. So here comes, now, what are the data, that is information required for this disaster management? There are basically 4 categories of information that we need, and that will be something will be very important for us to discuss. Basically, data on disaster phenomena. Before I go, am I still with the audience? Am I audible? Am I live still?
Yes, very much, sir.
Yeah, okay.
Yes.
Because I cannot see the audience. I can just see my slide, so that's why I'm a little bit worried whether I'm still there or not. So please, in between, anyone can say hello that we are on. Okay, fine. So as I said, the data that are required are data on the disaster phenomenon. That is what has happened: landslide, flood, earthquakes, anything like where is that happened, what is the frequency, what is the magnitude. We want to have this information if we want to respond to the disaster. So we would like to know, like flood has happened, Assam, which part, Upper Assam, Lower Assam, where, Barak Valley, where exactly, the location is important. What is the magnitude of it? How many villages are under the water? So we would like to know those kind of things. So this is very, very important for us to have this kind of information if we want to manage this disaster. Again, data on the environment in which the disaster event might take place, like the topography of it, the geological aspect of it, geomorphology aspect of it, soil, hydrology, land use, vegetation, so that we can plan how do we do the rescue operations, where do we have our shelters, where do we have our stock points or our warehouses to keep this thing. So we need to have this kind of information. So we need information about the environment of that particular area. So that is very, very important. Similarly, data on the element that might be destroyed. What are the things that are destroyed? That those informations are needed, like in the infrastructure, like which road has been blocked, which road has been blown away by the flood, which road has, which bridge has been under the water. So we would like to know about that infrastructure, the road, your bridges, our infrastructure, other infrastructure. Then we would like to know about the settlements, where these are being mostly affected, how much people are affected, what is the population size, what is the socio-economic condition of those people, so that we understand that what exactly kind of response we will need to have. So these are very, very important aspect information that we need. Similarly, we need information regarding on the emergency relief resources, like where are the nearby hospitals, where are the fire brigades, where are the police stations, where are the warehouses, so that we can immediately connect the people in need to do these facilities, so that they are rescued properly, they are provided the nursing that is needed at that time, or the medical facility that they needed at that time. So those kind of things can be provided. So we need to have those information. So those information, these informations are very, very important if you want to have a proper disaster management. And I introduced the concept of humanitarian logistics. Now, as I said, logistics is that part where we where we discuss about the movement of good from the point of origin to the point of consumption, so that the person, or so that we add value to each and every stage. But what is humanitarian logistics? It's a very special component of the branch of logistics, basically, where we specialize in organizing the delivery and the warehousing of supplies during natural disasters or complex emergencies to the affected area and people, so that they can have a basic normal life at that moment, so they can survive those disasters. So the main objective of an humanitarian logistics is to see what response they can give to the people who are in distress, who are in problem, so that they can survive that particular disaster moment, and later on they can go back to their normal life. So that it's been long processes there, but the logistical activities there are a lot of activities. If you see the chart that shows in the right hand side of this particular slide, you see that the primary input is what the need for the humanitarian relief, whereas the secondary input, the resources that comes, here is the thing that I think the remote sensing informations will be there needed, so that what output will go, the output will be the relief that we provide from the humanitarian activities. So this humanitarian relief is the output, whereas the need was the input, and the resources that we bring in, that could be any kind of resources, fund, data, information, and this is where remote sensing plays an important role. So how remote sensing will help us? Now I'm coming to the core of this webinar, basically remote sensing. So before going into that, let us have some sense of remote sensing. What exactly remote sensing means? I know there are a lot of people who know a lot about this, but I'm just briefly trying to talk about it so that we have a basic understanding, so that we can go ahead. Now, if you look into remote sensing, basically this is involved the contactless and aerial extension exploration of the Earth's surface. Basically, I'm just using the concept of remote sensing, where we means anything, any object that is above the ground, which takes the information about the ground, so that that information are of any use. Now, what is the key component on this remote sensing is the sensors. Okay, the remote sensing system carries the sensors, which are very, very important. Okay, which are very, very important. Now, which are very, very important. No. So this remote sensing, the sensors that are there are mostly important, like the passive sensors and the active sensors. Now there are different kind of sensors, so we'll not go more into this. These are more technical aspect of it. But what I would like to say, that this remote sensing are basically based on the sensors. So the sensors now, the development in this area is so rapidly developing, so these are improving a lot actually. So it is not only taking the pictures, that is the imagery, but sometimes it can be sound, sometimes it could be the radiation. Those are all now being used to collect the information from the ground. So this is something very, very important. Now, as I said, remote sensing sensors are important, but where are the sensors installed? This sensor are installed in, basically, if I say the satellite based, okay, this could be geostationary satellites, or it could be the satellites which revolves around the Earth. So that depends upon which technology we are talking about, or it could be airborne, like it could be unmanned air flights, or it could be balloons that are being used for some climate readings, or it could be some kind of your helicopters or others, or sometimes it can be drones also. Now this is also a new category that has been included in this remote sensing, which need to be which I think need a lot of attention, because drones have been doing wonderful in providing remote sensing informations, and which has helped a lot in disaster management. So these are the things, that new things that are being coming in. So where it's installed, basically I've categorized it into three parts: satellite based, airborne, and drones. Okay, so this is a little bit idea about the remote sensing. Now what it creates, as I said, it creates some data. That data could be in the form of image, that data could be in the form of electromagnetic waves or infrared waves, or many other things which technically I will not be able to explain myself here. So I'm just saying that these are a lot of information that this remote sensing equipment, the sensors, creates, and this provided to. If you look into this particular this picture here, you can see the satellites, the things, drones. They are categorized. They are taking these things, and these are used by the softwares, used by the people to create image, to create some kind of analysis, to do analysis. So these are something very, very important. Okay, that's how these data are utilized. Now, remote sensing data are used for basically, when I come to my humanitarian aspect, the disaster management. It basically, this remote sense data are actively utilized. This is utilized for quick assessing, basically to understand the impact of the severity of the flood or the earthquakes or the oil spills or any other disaster that we are talking about. So it gives us the idea about what is the impact of that damage, where it has happened. So those kind of things. This is also, remote sensing data can also be very effectively utilized in planning, efficient planning for evacuation, because this is very, very important. When disaster happen, we need to move out the people from there. Like if earthquake, then we need to, we cannot keep people there. We need to take out from there the collapsed houses or the houses which are going to collapse. We need to remove from there. If it's a flood, we need to empty the villages. We need to take out the people from the cities or the villages where the flood is coming, so that we can settle them somewhere else temporarily. So there are a lot of escape that it has to be done, and this is something very, very logistics aspect, which will be the best way to take out where we can take them and keep, so that the consequences will not be there in that location, or sometimes this escape route could be very, very important when there is when the radiation which has an impact on the large area. So in this way, we need to kind of find the escape route, or maybe during the hurricane or cyclone that we see here. So those are very, very important aspect, planning, and this planning is possible when we get data from the remote sensing. I'll talk more about it also. And we can try to chart out the quickest route that an ambulance can reach there, or the support can reach there to the victims. So these are some of the informations that we need from the remote sensing, so that we can plan those things. We relocate the shelter for the victims or the refugees in that case. Like the remote sensing can also be used for finding how many refugees are coming in. Like the Syria problem could create a lot of refugee in the border of Germany or in the border of the Turkey. So that geosensing provided the data that the refugee proportion is increasing day by day, and then the other side has to take some immediate steps. So these are all because physically they cannot go there on the other side of the border, so they have been using the stationary or the satellites to get the idea about what is the size of the population there. So those things are very, very important, actually, this information for, as I said, calculating the population density in the disaster-prone area. So we can, from the remote sensing data, we can have this idea about what is the density of the people there, or we can also identify some of the area where there is a potential of danger. We can rectify that. We can tell them in advance. So those things are there. We can get this pre-disaster assessment to facilitate planning for timely evacuation during the or the recovery operation during a crisis. So these things need all sensor data. Monitoring the reconstruction or rehabilitation after the disaster, that also is needed. Developing, maintaining, or updating the accurate base maps, because the humanitarian people who are in the ground, who are in the zero, what we call this ground zero, they need maps. They need information about which road is open, which place is good enough for them to travel, where they can move. So those informations are needed, and that is provided by the remote sense data. So these are some of the scattered way that I talked about. So let us see some real life things. Like if you see these pictures, these are aerial pictures. These are the remote sensing data that created this particular pictures. It shows the flood affected area. So we can say, like, from the pictures, like which villages, which areas are being under the flood. So that basically gives an idea for the planners that what is the scale of this disaster, what should be the level of the response, Okay, what level of response it needed. So those things are very, very important. Which are the infrastructure affected by this provide that particular things. So like this is an earthquake, before and after earthquake. If you see a picture which was before and then after the earthquake, then we can see that where the impact was, where we should start our rescue operation. So this gives an idea, because the humanitarian people or the people from those who are social workers, they don't know where to start from. Maybe this information will give them an idea, planning that okay, we should start from here because this seems to be most severely affected. So that kind of things are very important with this kind of information. Now, if you see this one, oil spillage of different area, so it gives an idea about where the oil has spilled, so that they can, and this is very common with we here, and recently also in Indian Ocean, I think there was oil spillage which has very severely affected the Mauritius area, I think. So we get to see from the top, from these images, what is the scale of that disaster and how do we manage that. So this is and this is basically tsunami, which I talked about, like basically before and after. So it gives an idea that what is the scale of the impact. So, and we can immediately respond and see which infrastructures are there. If you see that one of the bridges which was connecting the island is now damaged, whereas the other link is still open. So this gives an idea that which route to take and which route not to take. So that is something very, very important in the crisis moment, to when we are managing the disaster. And this is very recent pictures from the California smoke or the fire that is taking place, and we see that how it has impact the environment. And from the satellite image, we can make an assessment of the impact of the smoke or the fire, and that can make a proper planning. So even last year in Australia, we saw the huge fire. Similarly, we see the same crisis here in California now, in the United States. So these are the things that gives us an idea about what exactly the image can do. I'd like to go a little bit about humanitarian uses of remote sensings. Now, the first thing that I talked earlier about the importance, how it is used, but let us now look into technically. In assessment, it helps basically. Remote sensing helps us in disaster management, basically the humanitarian disaster management in the form of remote sensing, in the form of assessment. Like, let us see what kind of assessment. Basically, if you see, this is the major application of remote sensing in humanitarian operations. It's the most largest and the most diverse area of application. The aerial image and the result maps are used to evaluate the extent of this disaster, or to get an overview of the disaster. So that is what, and as it helps in assessment. Determine the scope of the help required. This is something very, very important, because the international community will need to respond. So they will first need to assess what kind of response they will have. Do the response need to be immediate, or in large scale, or in small scale? So that is something very, very important for any local government, to the national government, to the international community. They need to know this basically. Similarly, to decide if intervention is needed, as I said, depending upon the assessment, they decide about intervention. How best to start, from where, which place to start, because everywhere the requirement is there, but from where to start. So that also is helped by this remote sensing information in helping assessment. Search and rescue activities is there, and determination of demand of regarding relief communities. What kind of relief communities should we take there? That is also being assessed when we get information from remote sensing. Do we need medical? Do we need infrastructure? What kind of assessment communities should we take there? So that basically are very, very important actually in the assessment. So also it helps in disaster mitigating. I mean, how do we minimize this? So basically, through better future scenario prediction, like we can talk about the cyclone development. Nowadays, any cyclone is it does not go unreported. I think even if it's a small one or the large one, it's always being reported. And this has helped the people who live in the coastal area immensely, because now they know in advance that there is going to be a cyclone. So that's how they can minimize their movement. They can minimize their, prepare accordingly, so that they can minimize their destruction accordingly. So this is something very, very good in minimizing minimizing the disaster. Similarly, Remote sensing can also help us in identifying the disaster prone area, especially when the flood is coming, because flood also takes time to come. So slowly, because remote sensing, basically we call it mapping. So when there is a continuous record of data that, okay, it's slowly increasing, now there is a chance that it will have an impact on these areas. So people may get a chance to move from there before any disaster happens there. So that basically is there, this kind of information. Um, as I said, people can identify the vulnerability, and management also can understand who are more vulnerable. So try to help from that point of group. Uh, Basically, also it helps in location. How do we protect? Where do we make the constructions? How do we do this kind of things? Because I remember, like, this was in last season when in certain part of England the dam was filling up because of the heavy rain, and they were trying to see that if the dam collapses, then the whole village under the which were lying below that level. So they created the proper kind of mechanism of protection, so that it helped that particular village. And I followed that particular news in BBC very continuously, and I could see that they have used a lot of remote sensing images to see where they need to create those protections, so that the villages down the line are safe. So those kind of things can be very useful in mitigating the disaster, and that is coming from the remote sensing. Okay, and also from the recovery. So after the disaster has happened, we can recover with the help of this information. Monitoring is also there. As I said, remote sensing helps in monitoring also. Monitoring where when
Thapalia sir. Hello, Thapalia sir. Thapalia sir.
Shukar sir, Thapalia sir's voice is not coming.
Thapalia sir.
Something network problem. So it may be.
I think it's disconnected.
Thapalia sir. Okay.
Network problem hoise na.
I think it's disconnected. Thapalia sir. I think he is disconnected. Thank you, sir, for your valuable and informative presentation. You have clearly discussed how to minimize the negative impact of the disaster and channel the resources to bring back society to normalization. We also focus on why disaster is to manage and what are the ways we can manage it. Thank you very much. Thank you very much, sir. Yes, sir. Today invite another resource person, Dr. Kiranmoy Sharma, sir. Kiranmoy Sharma, sir, am I audible?
Yes, sir. Yes, sir. I'm ready.
So
I'm ready with my presentation.
Okay. Then I introduce Dr. Kiranmoy Sharma, sir, to the participants. Dr. Sharma, sir, presently working as associate professor at the University School of Environment Management, GGS University. He has got MSc degree in Geoinformation and Earth Observation from International Institute of Geoinformation Science and Earth Observation, ITC, Netherlands, and in Geography from Guwahati University. He did PhD from Northeastern Hilly University, Shillong. His expertise in remote sensing and GIS application in environment management, natural and disaster management. He has published more than 95 research papers in various reputed national and international journals, edited books, conference proceedings. He has authored 7 books in the sector of environment. 3 PhD degrees have already awarded under his guidance. One has submitted and 5 other scholars are currently pursuing their PhD research work in the field of environment. He completed a good number of research projects of various scientific organizations. May I request Dr. Kiranmoy Sharma sir to present his presentation? May I audible, Sharma sir?
Yes, sir. Thank you very much, sir, for the nice introduction. So, respected Principal, sir, Sarabhahi College, Dr. Kamal Chandranath, Coordinator, Dr. Deka, distinguished speaker of today's webinar, Professor Biju Thapalia. It was pleasure listening you, sir. It was very much relevant, and hope everyone got benefited from your deliberation. Respected faculty members of Sarabhahi College, all the participants, and my dear students. And okay, can I share my presentation? Should I share my presentation? And there are 2 humble requests to all the participants. Please mute yourself during the deliberation, and please do not try to open presentations while my deliberation is going on, because we have already seen during the last presentation that we got some technical issues. We could not see even the slides properly. So please do not try to open the presentation from any of you during the deliberation. After my presentation is over, please, we can do whatever we feel like, but during my presentation, please do not open it. Thank you very much. Is it coming?
No, sir.
Presentation is not coming?
Not, sir.
No, is it coming, sir?
Huh?
Is it visible? It is visible, sir.
It's covering full screen, I believe. Is it covering full screen?
Yeah, it's coming.
Visible.
Okay, right. Okay.
Shakrana?
Okay. Should I start?
Yeah, yes, Kiranmoy sir, you can start. I think I got disconnected.
Okay. Thank you. Okay. Again, I welcome each and everyone to this particular session. And basically, I'll be discussing in this particular deliberation about the basic principle of remote sensing and its scope. And second part, probably I'll be more giving emphasis on the disaster management and its remote sensing application in that particular aspect. So let's start with the basic principle of remote sensing. So being a common man, what's our understanding about the subject remote sensing is? It's using an instrument to record an object or phenomena of the surface of the earth without coming into physical contact. That's what we understand till this point about the subject remote sensing being a layman. To getting any photograph from elevated platform, we need to have a source of light. Sun rays hit the surface of the earth, and different objects present on the surface of the earth, they start reflecting back the incident energy. And these reflected energies are captured by the sensor mounted in the satellite. Once these signals are received by the sensor, this signal is sent to the processing unit. And in processing unit, these energies, these reflected energies are captured in a pixel. That pixels make up the complete study area or complete scene that is sensed. This is how we get an satellite imagery. So to know detail about the satellite technology, we have to go to our school days to understand about the electromagnetic spectrum. Electromagnetic spectrum has big contribution in the field of remote sensing. So what is electromagnetic spectrum? It's an arrangement of light based on the wavelength, the radio and TV waves, that's the longest wavelength we have, and gamma rays, those are the shortest wavelengths. So in between we have gamma rays, X-rays, UV rays, visible IR, infrared, microwave, then the radio and TV waves. Where all these lights are arranged based on the wavelength we call as the electromagnetic. Already I have mentioned, like electromagnetic spectrum having big contribution in the field of remote sensing. Okay, in the proceeding slides, probably I'll be discussing in detail about this. Okay, our first understanding about the remote sensing is using instruments to record an object or surface without touching it. Most techniques make use of the electromagnetic spectrum. When the term remote sensing comes to our mind, the satellite terms automatically appears to us. What is satellite? Satellite is a body in the orbit around another body. It has many different purposes. They may be a part of a television or telephone network, environmental monitoring, weather forecasting, or they can carry instruments to investigate the Earth's surface or Earth's atmosphere. The stages that I just explained, like what are the different stages involved in remote sensing, that definitely there is a requirement of source of energy. The sun is a source of energy when we talk about the passive type of remote sensing. And transmission of energy from the source to the Earth's surface, and in between source to the surface, there is again introduction of energies in the atmosphere. So most part of the energy receives the surface of the Earth. Once it hit the surface of the Earth, they start getting reflecting back by different objects. So transmission of energy from the surface to the remote sensor, sensor data output, data transmission, and the processing and the analysis. These are the different stages that involved in a passive type of remote sensing. Okay, we know that light always travel in wave-like structure or sinusoidal form. So when the sun rays hit the surface of the Earth, depending on the capability of different objects, depending on the albedo, different objects will start deflecting the incident energy in some proportion. If it is clean water, we know that water cannot reflect. If it is distilled water, all the energies that hit that particular area, all energies will be absorbed. There will not be any reflectance. But there are objects like concrete, snow, cloud, they have maximum reflectance capability. So they will reflect maximum incident energy in the form of reflectance. And these reflected energies are captured in the sensor mounted in the satellite. And these all energies are captured in the sensor. Once these are stored in the sensor, then they send a signal to the processing unit. And processing unit, they send this signal for the processes. Once these signals are processed, then imageries are formed. These imageries are composed of pixels. Pixels carry the reflected energy of different objects. The range of values that individual pixel can have starts from 0 to 255. It's all, if all energies are absorbed, like example I gave you, that distilled water. In case of distilled water, probably the reflectance will be minimum. The value that those pixels representing the clean water will be minimum, maybe 0 to 10 or 15, something like that. If it is cloud or concrete, the pixels for those areas will be having very high pixel value. It is called DN, digital number, probably 200 and above. So depending on the reflectance, we can have different DN values for different pixels who are representing different objects of the surface of the Earth. In this way, we can have satellite remote sensing. Once we get this type of data, this data can be utilized for many developmental activities. Okay, another type of remotely sensed data we have, that is aerial photograph. In this case, camera is mounted in the aircraft, and along the strip, imagery are acquired mainly in case of disaster management when data is required for very short duration of time or a very particular area where satellite doesn't have the coverage. In that case, aerial photographs are widely utilized. This is how we can have remotely sensed imagery, satellite imagery, and the aerial photographs. So I have already mentioned about the electromagnetic spectrum, though we studied in our very initial days, but repeatedly I have been telling that it's having big implication in remote sensing. So in remote sensing, basically, from the electromagnetic spectra, from visible to microwave portion of electromagnetic spectrum is utilized. Also, it is called the windows that is used in remote sensing. So whatever we see, we use 0.4 to 0.7 micrometer portion of the electromagnetic spectrum. So beyond that, our eyes cannot detect. Imagery taken from the elevated platform. Whatever resources available below the sensor, everything can be captured in that particular image, where there are forest, where there is settlement area, where there are agricultural land, where there are water bodies, and so on. Everything, whatever available on the surface of the earth, those will be captured in that particular imagery if we use visible portion of electromagnetic spectrum. Again, there are many phenomena that goes beyond our visible domain. Like when we talk about disaster management, there are subsurface or underground fire in many coal mine areas. Probably you are aware in Cheria coalfield or India, there are underground fires going on years. Those are uncontrollable fires. And those type of fires cannot be seen in an imagery if it is taken using visible portion of electromagnetic spectrum. Again, beyond visible spectra, we have infrared, near infrared, mid infrared, and the thermal infrared. Thermal infrared, if we have an imagery using the thermal infrared, that imagery can tell us about the differences in the temperature. If we have that particular imagery for that particular area, that warmer area will be having different signatures to the areas which are experiencing normal temperature. In that way, we can map those areas where there are underground fire. Again, microwave remote sensing. This is the longest wavelength used in remote sensing. The characteristics of microwave remote sensing is that it can penetrate through any unwanted substances like haze, smoke, clouds. If there is obstacles in between camera and the target, then those obstacles can be overcome by this longest type of wavelength. For flood disasters, for flood mapping, microwave remote sensing is having wide applicability because of its unique characteristics. Morigao district, frequently, not only Morigao, entire Brahmaputra and Barak Valley, they are experiencing flood every year. For flood mapping, because most of the flood we get because of the rainfall, moisture bearing rainfall, sensor is there, flood is there, in between there is cloud cover. In optical remote sensing, in the image, only clouds will be appearing. But if you use microwave remote sensing, then you can see what is down to the cloud, and all flood inundated areas can be mapped. So these are the unique advantages of having satellite remote sensing. Whatever we see, it's fine. Everything can be seen. Whatever we cannot see, we can simply imagine. Those things also can be acquired by this particular technology, and it has wide applicability in the field of disaster management. Okay, I have already told you that human eyes only measure the visible land, that is 0.4 to 0.7 portion of electromagnetic spectrum. Sensors can measure other portion of the electromagnetic spectrum, that is beyond the visible portion of electromagnetic spectrum. Same area, probably Morigao district, can be seen by using other portion of electromagnetic spectrum besides the visible portion. It has applicability. I'll be discussing those things. What's the utilities of having different bands to acquire a single area using different bands? What's the utilities I'll be discussing in my coming slides. Okay, by now probably we are confident what is, we can recall the topic we studied in our school days, that what is electromagnetic spectrum. Electromagnetic spectrum is a continuum consisting of the ordered arrangement of radiation according to the wavelength or frequency or energy. A total range of wavelengths extending from gamma rays to radio waves is referred as the electromagnetic spectrum. I was talking about thermal imagery. So this is an imagery from China, from a coal mine areas where there are underground fires. So this is nighttime imagery. The bright signatures are the areas which are warmer than the surrounding areas. These warmer areas are because of the presence of underground fire, except the bigger portion in the center, bottom left. All bright signatures are because of the underground fire. That big spot is a water body, because nighttime water bodies are warmer than the land masses because of the maritime and continental effect. Daytime it's just rivers. So nighttime waters are warmer. So warmer water are appearing in different signatures than the surrounding areas. So in this way, we can have imagery that are experiencing different range of temperature, and we can map those. Okay, SWOT is simply the area that is covered by the sensor. So sensors collect 2D images of the surface in a SWOT below the sensor. Landsat, this is a camera, least 141 kilometer by 141 kilometer. That size of the scene. The Landsat, it has 185 kilometer by 185 kilometer area. This can be acquired along the strip or across the strip for the acquisition. Okay, by now probably we are confident about the satellite imagery. So imagery are composed of pixels, and pixels represent the object. How these objects are represented? These objects are represented by their reflectance energy. So these reflected energies are captured by the pixels, and pixels form the entire study area. So what is image? Image is data which are organized in rows and columns, normally represent a geographical area. That's what our understanding till this point about the satellite imagery. So data that are organized in a grid of columns and rows normally represent a geographical area. This image can be for very large country, and we know these are the days of digital. So all imagery are composed of pixels, and these pixels are arranged in rows and columns. This is our understanding about the satellite imagery till this point. Okay. By now, we are confident about the remotely sensed imagery. All pixels, they carry some values ranging from 0 to 255, depending on the albedo or reflectance capability of the objects. So that particular imagery, all the pixels carry some numerical values, means these imagery are of quantitative in nature. When, and data we call as a quantitative data, when that particular data possesses values, numerical values. So these are the quantitative type of data. Remotely sensed imagery are quantitative type of data. All of us are aware about the satellite Google Earth or Google Earth imagery or satellite imagery. Suppose we have an imagery for Morrigaon district. In that particular imagery, we can see many resources. All resources that can be seen from the elevated platform, all will be appearing in that particular image. In that particular image, oh, we could see these are the water bodies. These are the areas of forest. These are the areas of agricultural land. These are the areas of settlement area. These are the area of tea gardens. In this way, few resources we can identify for the Morrigaon district. Again, we know these objects represented by pixels, and pixels carry some value. Suppose that particular imagery for Morrigaon district having the range of pixels from 10 to 200, because getting 0 or getting 255, practically it is not possible. It is possible only in the laboratory experiments. So the image we have for Morrigaon district, the range of pixel is from 10 to 200. So we could identify the water body. These are the area for water body, and we'll take out the pixels for the water body, and we'll find that the pixel value for water body ranges from 10 to 50. So whatever pixels we have for water body, the DN is ranges from 10 to 50, because water having capability of absorption. This reflectance is because of the pollutant present in the water. If sediments present in the water, those sediment will reflect, of course. If it is clean water, then DN value will be minimum. Okay, fine. For water, we have 10 to 50, 50 to 80, suppose it is for agricultural land. Agricultural land also having water in that. 80 to 120, it is for forest area. 120 to 150, it is for suppose forest open land. 150 to 200, it is for the settlement areas. So all these range we have clubbed in 5 clusters. This range is for water body, this range is for agricultural land, this range is for forest area, this range is for open land, and last cluster is for the settlement area. So we have converted those range and assigned some name. So once we assign name to the quantitative data, those quantitative data will be converted into some discrete data or qualitative data. So those range of values assign some classes, and once we have assigned some classes, those remotely sensed data are converted into a particular type of data that is called a thematic data or thematic imagery, data with a particular theme. Land use land cover map, soil map, geology map, forest type map, forest density map. All these different type of maps are the outcome of the remotely sensed data, which are continuous type of data, and these resultant imagery are of the thematic type of data. In this way, we can have 2 different type of broad data types, remotely sensed data and the thematic data. Okay, when we talk about the remotely sensed data, again, this could be of 2 types. If you remember the electromagnetic spectrum, when one band from the electromagnetic spectrum is used, then it is called a panchromatic data. So to have a view of any object, we have to combine 3 colors. To get a particular color, we have to combine any proportion of 3 primary colors, that is blue, green, and red. But by combining these 3 colors in some proportion, then only we can have a particular color. Omitting any from these 3, we cannot have a definite color of that particular object. So to have a particular view, we have to have 3 colors in some combination. But in case of remote sensing also, whenever we see an object, we have to combine 3 bands at one go, then only we can have a view of a particular area. But in case of panchromatic imagery, as we have only 1 band used, so these imagery are of grayscale imagery or black and white imagery. Another type of remotely sensed imagery is the multispectral imagery, where 2 and more than 2 bands are used. As more bands are used, so we can have spectral differences, we can have color differences in these multispectral imagery. So in this way, imageries can be having 2 types. One is panchromatic and another is multispectral, depending on the range of electromagnetic spectrum used. Okay, this is how multispectral imagery look like. Yeah, if you see this particular image, there are many objects, of course, color, tone, texture, brightness. different objects are representing different types. So we can identify where there are water bodies, where there is settlement area, where there are agricultural land, where there is forest area. So all can be identified, and giving the spectral range, giving the range of DN, this can be converted into a thematic imagery. We know the size of the pixel, we know the number of the pixels, so we know how much area under water body, how much area is under dense forest, how much area under open forest, how much area under degraded forest, and so on. So all can be represented in tabular form, it's attribute data. Okay, fine. Till this point, we have been in remote sensing. So I'm going a bit fast today because of the time constraint, because time given to me is up to 11:50. So I started late. So probably if I'm very fast or slow, or if I'm okay, please give the feedback in between. I cannot see any of you. So if any problem, please, organizer, you can give a call to my mobile, or you can straightaway tell if it is you are getting any problem. And anyway, so characteristics of remote sensing data. So satellite imagery is available in digital form. By now we're confident. Resulting imagery are made up of grid of pixels. Each pixel stores a digital number measured by the sensor, ranging from 0 to 255, represents individual areas scanned by the sensor. The smaller the pixel, the easier it is to see detail. So what? Fine, up to point number 4, it's fine, we have already discussed. So it is written, the smaller the pixel, the easier it is to see detail. Okay, all of us are aware about the Google imagery. Whenever we see open a Google imagery, because these are very high spatial resolution imagery, we try to locate our known places. Probably our first focus will be where my house is located. In Google imagery, most of the objects can be seen. If you have observed in the bottom right, it is written GeoEye for urban area basically. Sometimes it is written Iconos, sometimes it is written QuickBird. These are the name of the sensors used to capture that particular image. If it is written GeoEye, most of the imagery are of GeoEye sensor. So if it is written GeoEye, that pixel size is 0.5 meter into 0.5 meter. If it is written QuickBird, the pixel size is 0.61 meter into 0.61 meter. If it is Iconos, if it is written Iconos, then pixel size will be 1 meter by 1 meter. So spatial resolution of that particular imagery of these maybe 0.5, maybe 0.61, maybe 1 meter. So in 1 meter pixel size imagery, object equal to or more than 1 meter size can be seen in that particular image. Smaller than 1 meter size object cannot be seen in an imagery with 1 meter spatial resolution. So even in Google imagery, we can see the vehicle part. These vehicles are bigger than the pixel size. So these are very high spatial resolution imagery where pixel size are very small. Normally for the urban study, if we go for any type of urban study where inch also matters, we use these high spatial resolution imagery. But we can have different objectives. My study area is not confined to a small urban area. My study area is a larger entity. Maybe for the entire Morrigan district is my study area. In that case, I do not want the information for each and every household in the imagery. I'll be more interested where settlement areas are located, where different type of forests are found, where there are dense forests, where there are degraded forests, where there are open forests, where there are water bodies, where there are agricultural land, where there are tea gardens. Maybe I'll be interested for 8 to 10 different type of objects or phenomena for the entire district. In that case, I'll go for an imagery where pixel size is bigger than 1 meter or 0.5 meter. Probably I'll be going for regional resolution imagery like 20 to 30 meter spatial resolution, where these 8 to 10 different type of resources can be acquired. Fine. Two different resolution having different implications. Again, I may not be interested for a district level interpretation. My area of study is very big. For entire Northeast, I am concentrating. In that case, again, I will not be interested different type of forest density, where there is dense forest, degraded forest, open forest, sitting cultivation areas. Probably I will not be interested for this much detail. For my objective is just to map where there are forests, where there are agricultural land, where there are settlement areas, where there are snow-capped mountains, where there are water bodies. 5, 6 resources I can identify for that large area like Northeast. For this, again, we'll be using an imagery with bigger pixel size, maybe 70 to 80 meter pixel size we can utilize for this type of interpretation. The first one, fine. Second one, normally Landsat, LIS3, that IRS remote sensing, those type of imagery we can utilize. For Northeast, we can use Landsat MSS, where 80 meter pixel size, 80 meter spatial resolution. But now we are confident that smaller than that pixel, we cannot see the object in that particular image. There are imagery with very big pixel size, like one pixel is of 1 kilometer size. NOAA, it's having 4 kilometer size. 1 pixel is of 4 kilometer size, 4 kilometer by 4 kilometer. In those imagery, we cannot see the object, which is smaller than 4 kilometer or 1 kilometer. Then immediately things come to our mind. What's the utility of having this poor or coarse spatial resolution imagery? But yes, it has application in their respective field. Meteorological data, they are having very coarse spatial resolution imagery. The one I told you, NOAA, Landsat, these are NOAA, then INSAT. These are the meteorological satellite having very coarse spatial resolution, but it has wide area coverages. At one go, they can see the entire hemisphere of the globe. And where there are moisture-bearing cloud, where there is generation of cyclone. So these are the information we can see in a global scale. Every day we are seeing in TV that these are the movement of the clouds. These are the initiation of cyclone. So once we can see this phenomena, then cyclone is generated here. Again, if we have core spatial resolution imagery, those imageries are taken in very short duration of time. It is taken now, after half an hour, we'll be having the imagery. The cyclone is here, after half an hour, what's the location of the cyclone? After half an hour, where that cyclone has reached. So we'll know at what speed cyclone is proceeding and in which direction it is following. So we know the velocity. So if we know the velocity, after how many hours that cyclone would reach the coast, so that people can be warned and evacuated before the cyclone hit the area. The success story of Hurur, then success story of Bulbul, success story of Amphan. These are the outcome of this technology. People could be aware, people could be informed well ahead so that their life and properties can be saved. So in this way, we can have utilities of different imagery. Fine. I was talking about the acquisition, the time difference between two acquisition. When we talk about the meteorological data, the time acquisition should be very short. Maybe half an hour or 10 minutes, 15 minutes. That is also called the rapidity. So that is a time duration between two acquisition is called the rapidity or temporal resolution. That first one, we're talking about the pixel, it's a spatial resolution. What is spatial resolution? The size of the art that is captured, that is represented by individual pixel is the spatial resolution of that particular imagery. What is temporal resolution? Temporal resolution is the time differences between two acquisitions. Meteorological satellite having very good temporal resolution. Rapidity is very fast. When we talk about, those are geostationary satellites. When we talk about the remote sensing satellite, the temporal resolution is poor. If Morigaon is sensed today, maybe after 20, 30 days, this area will be sensed again. The differences between these two acquisition is the rapidity or temporal resolution of that particular satellite. Fine. These two resolution types, I believe you are confident enough by now. We are talking about the electromagnetic spectrum. We are discussing about the panchromatic data. Panchromatic imagery are of black and white in color. So our main objective is, those are the data. From data, we have to extract maximum information. The drawback we have in panchromatic is that, as there is no color differences, we may not be recognizing many objects from that particular area. So spectrally, panchromatic imagery are poorer. But multispectral or hyperspectral remote sensing, where we use two or more than two bands, where we can have spectral differences or color differences, those are the imagery are better in terms of spectral resolution. So in this way, we can have three different types of resolution: spatial resolution, temporal resolution, and the spectral resolution, the range of the electromagnetic spectrum used. Another type of resolution also we use in remote sensing, that is the radiometric resolution. Radiometric resolution tells about the properties of individual pixel, like 8-bit data, 16-bit data, 32-bit data, 64-bit data. So it tells about the quality of the pixel it represents. So when technically it is the smallest difference between two radiated energies, the radiometric resolution of that particular sensor. So in this way, we have four different types of resolution, starting from spatial resolution, temporal resolution, spectral resolution, and the radiometric resolution. So this is how we can test our understanding. Ability of the sensor to give the information at the smallest discretely separable quantity in terms of distance, wavelength, band of electromagnetic radiation, time, and the radiation quantity. Spatial resolution defines the size of the Earth's surface, that is stored. Please do not speak in between, please. It's my humble request. I get disturbed. Spectral resolution defines the ability of the sensor to define the wavelength intervals. Temporal resolution defines the rapidity of the satellite. Radiometric resolution defines the range of the values that an individual pixel can. Already I have explained it. You can see the sensors and the respective resolution of against each sensor. So in this particular satellite, we have 5 different sensors, like 3 from visible band, then infrared, then the panchromatic. In that particular satellite, we have 5 sensors. We have 5 different bands. Radiometric resolution, that's the smallest difference in radian that can be detected, as is expressed as radiometric resolution. Temporal resolution is the rapidity, time difference between 2 acquisitions. Okay, I have kept here 4 different imagery with different spatial resolution. First one is ICONOS 1 meter, SPOT 10 meter, Landsat TM and ETM, that is 30 meter resolution, and Landsat MSS, that is 80 meter resolution. So we can have different view of these 4 different imagery. TM or ETM, TM is a sensor in Landsat satellite. TM means thematic mapper. Name of the camera or sensor is the TM, thematic mapper or enhanced thematic mapper. These 2 cameras are used in Landsat to get an image with 30 meter spatial resolution. In MSS, multispectral scanner, this is in the, I was talking about the Northeast. For Northeast, probably I will be using this type of data. Landsat MSS, multispectral scanner with 80 meter spatial resolution. 1 meter, 10 meter, 30 meter, and the 80 meter pixel size imagery. Again, so I am still in the spatial resolution. This is 80 meter Landsat. For the entire Northeast, we have information around 5-6 different resources from this image, maybe this 80 meter spatial resolution. Now we'll come to Morigaon, where we should have some more information. For that, we have to use a resolution with smaller pixel size, maybe 30 meter pixel size. Here, more information are appearing than the Landsat MSS. Then from Morigaon, again, Morigaon district, again, I want to have the information about the Morigaon town. In that case, I'll go for an image with high spatial resolution, maybe 10 meter spatial resolution imagery, where many objects can be easily identified. I have to map the Saraibahi College of Morigaon. In that case, I'll go for an imagery with very high spatial resolution, maybe 1 meter spatial resolution imagery, where each and every department, each and every trees, each and every object can be seen and can be mapped. In this way, we can have utilities of different resolution imagery. Again, I'm still in the resolution. Suppose in the Google imagery, I was talking about the GeoEye 0.5 meter spatial resolution. Up to this much detail, we can see an object. Because pixel size is 0.5 meter, object equal to or more than 0.5 meter can be seen in the particular image. If you want to make for more zoom, then your image will start breaking. So without changing the scale, just I'm increasing the size of the pixel from 5 meter to 5.5 meter to 5 meter. Then this entire area are shown in some broken pixels. From 5 meter, I'm increasing the pixel size to 25 meter. Then entire area is coming in some countable number of pixels. From 25 meter to 50 meter, so entire area is coming in 1 or 2 pixels. In this way, different resolution, it matters, and accordingly, we can utilize it. Okay, so these are all spatial resolution. Suppose we have 5 bands from a particular sensor, 3 from visible band, 1 in near infrared, and 1 short wave infrared. 2, 3, and 4. Because to get information about the vegetation, we have to use the near infrared band, because vegetation having maximum reflectance in the near infrared band. That's why vegetation always appear red in color, right? So in these 3 combination, we have a view for a particular area in this particular way. So we'll simply change the band from 2, 3, 4 to 3, 4, and 5. Same area can be seen in this particular way, because we are approaching, if you imagine the electromagnetic spectrum, we are approaching towards the thermal band. So this image is telling about the temperature differences in that area. Warmer areas are coming in different signatures, and the colder areas are coming in different signatures. In this way, we can have those information. We are not considering the IR portion where vegetation will not be appearing. Then simply we can go blue, green, and red. Same area we can have in this particular way. So why we go for all these permutation and combinations? Yes, this is the image we have. I am interested for natural resource management. So in that case, I'm interested where there are natural resources. In that case, I'll combine my bands in such a way that vegetation will be appearing, and I'll extract the vegetation, and whatever objective I have, I'll go for these vegetated areas. I'm not interested for natural resources. I'm a town planner, I'm a builder. So my focus is where there are settlements. And in that case, I'll combine the bands in such a way that all buildings will be highlighted, and I'll take out, and according to my objective, I'll into this area for further research or further study. So in this way, okay, this is the image. So well, almost I'm done. So okay, this is an image. This confluence of Brahmaputra and Ganges. The horizontal one, black one is the Ganges, and vertical one is the Brahmaputra. Brahmaputra water is appearing bright in color, but Ganges is appearing dark in color. But in remote sensing, okay, if it is if someone asks me which one is cleaner, in normal view, definitely we'll say that black means this is dirty, but it is just reverse, because if it is clean water, then maximum absorption, and as there is minimum reflectance, those area will be appearing blackish in color. Brahmaputra, this brightness is not because of the cleanliness of the water, but this brightness is because of the sediment present in the water, because water cannot reflect. The reflectance is because of the sediment present in the water. So that's why we are having different signatures for Brahmaputra and the Ganges. So in geography, normally we are very much concerned about the landform. This imagery tells about the river pattern. We have meandering river, we have straight river, we have the braided channel. So there are again associated landforms, whether it is because of the tectonic upliftment, or because of the action of rivers, or it's because of the deposition along the foothills. So by studying different type of river pattern, we can associate different type of landforms. So it is again very much relevant for a geography student. This is the landforms in the volcanic region, caldera, pyroclastic flows. These are very much prominent. This is a flood inundation mapping of Kosi River. Again, different rocks will be absorbing and reflecting the incident energy in different proportion, and they will be appearing in different color. This texture, color, tonal differences can help us in differentiating different rock, and this can help us in preparing a geological map of a particular area. This is the shoreline lake of Silica in Orissa. This is again a mangrove forest of Sundarban in Bangladesh and in West Bengal. The dark color is dense mangrove forest, and pale red is the agricultural land. If there is presence of chlorophyll or presence of chlorophyll, then definitely because of the reflectance in the higher region, all vegetation will be appearing reddish in color in the false color composite. So in the top there is a black spot. This black spot is, now you're aware, this is a wetland or water body. Yeah, this is the harvested cropland of Uzbekistan. This is the Marsi Indus River of Pakistan coast. This is our very much own Brahmaputra River. That sandbar we have sandbars are occupied for agricultural purposes. In the bottom left, we have that strip of airport, the Deeporbill, the dense forest area, the Maligaon, those areas, Jalukbari area. So this is again the image of Guwahati. This is Landsat TM image. This is Landsat MS of and the northeast. This is again resource set image of 5.8 meter spatial resolution. This is QuickBird image, almost photographic image of a particular area, 0.61 meter. This is Iconos 1 meter spatial resolution. This is again. This is one of the imagery. And we know by now that all pixels having particular range, and giving the range of pixels, we can assign those pixels with some name and can be converted into some classes like dense forest, open forest, agricultural land, settlement area, water bodies, and so on. In this way, this project was done to map the elephant corridor in central India. So in this way, we can get the thematic map using digital image classification. But sometimes by seeing an imagery also, we can identify many areas. Immediately we can identify where there are water, where there are agricultural land, where there are woodland, where there are swampy area, and so on. Simply we put a tracing paper top of tracing paper, means the transparent paper top of this, and we will differentiate different objects considering tonal, tone, color, pattern, texture, association. These elements we take to differentiate different objects and verify with a field. And once field verification, then we can simply give the standard color and standard name to prepare a particular map of this type, Manas National Park. This type of interpretation is called visual image interpretation. Okay, so initially our understanding was using instrument to record an object or surface of the earth without coming into physical contact. So after having all this deliberation, probably we can update our understanding like the science of encoding, processing, and interpreting imagery. That's the result of the interaction between electromagnetic energy and the matter. So this is what we can update our understanding about the subject. Remote sensing is okay. If the organizer allows me to have around 5-10 minutes extra, then I'll be very much obliged. Okay. A few applications. One study we did in Sikkim. It is very easy to understand application. That's why every time I discuss with this one. Here, main objective was to identify the areas for afforestation program for the forest department in a watershed. We have different maps, different layers of that particular watershed. We have land use land cover map. Suppose in this particular map, we have forest area, grassland, agricultural land, and the degraded land. If I have to choose which area I'll select for afforestation program, definitely I'll look for the degraded land, followed by agricultural land. Forest area and agricultural area will not select it because these are already afforested, and agricultural land, that owner will not allow us to go for any government project in their land. So if we have option of giving weightages, definitely suppose 1 to 9 we have weightages, we'll give maximum weightage to the degraded land and minimum to the forest and the agricultural land. Similarly, in case of slope, probably accessible areas will give more weightage than the steep slope areas, because those areas are difficult to reach for the plantation activity. If we have a soil map for the same area, definitely we will not go for the rocky or sandy soil. We'll go for the areas which are having the fertile soil like alluvial, black, and loamy soil. So accordingly, we'll assign values. Maybe those are the areas will be giving the high values, maybe 8 or 9, and rocky and sandy soil will be giving 1 or 1, yes, because no point planting the seedlings because survival will not be there in those areas. Vegetation type, again, this is another layer we have. We'll go for the areas which are non-forest and degraded forests, and remaining will be giving the big weightages. Again, if we talk about the drainage, we'll select those areas which are near to the water body. Probably these are the areas we'll be selecting because this watering to the seedlings will be easier if we plant our seedling in these areas. So different maps with different values, different weightages we have. What we'll do, we'll superimpose these maps one after another. After superimposing all the maps, in the output map, we'll have some areas with very high values, some areas will be having moderate values, some areas will be having very low values. Depending on these values, we can say that these are the areas which are having high values and are best suitable for the plantation activity. After integrating all these different values from different maps, we could find out the dark green area as the maximum value, and will suggest that these are the areas plantation activity will have more beneficial than the other areas. This output was submitted to the Forest Department of Sikkim government. Okay. When we compare with the land use land cover, these are the areas best suitable, moderately suitable, and the least suitable areas. If you compare with the slope, yes, and soil probably, yeah. Forest type, this is the comparison. So this is the image we use to classify the land use land cover and the forest type map. So simply we interpret this imagery to know the land use land cover and the forest type map. And this, we are very much confident about the topographical sheet. These contours and the drainage nets are taken from the topographical. So this is one way how we can have suitable site for afforestation program. So this technique we use in other fields as well. So one project we did in Tawang district of Arunachal Pradesh. This was a project from MOEF, Ministry of Environment and Forest. And the objective of this project was to identify, they have the proposal of setting up micro hydroelectricity project. They have proposal for 13 sites, and we are asked to do the EIA, Environmental Impact Assessment Study, and my portion was to see the vulnerability probability of the impact areas. What we did, we studied different physical as well as cultural phenomena of the district and giving weightages. The one methods we used there, same method was used to identify the areas which are represented by high values. And based on that, we could identify 5 different classes: high, moderately high, moderately low, and low. So our object, these are the proposed location of those 13 hydroelectricity power plant. What we did, we used 10-kilometer radius to delineate a circle for the impact zone. What we did, we draw a circle taking 10-kilometer radius and took out the areas for each project site, and we could know how much area is vulnerable and in different classes for all the project sites. In this way, this EIA was carried out. And of course, first we are talking about the vegetation, floral, then this is related to somehow disaster. Then EIA, of course, we had some publications recently, so my PhD scholars. That what's the impact of thermal power plant on the land surface temperature? My SSC got awarded, and we had these 2 publications. One is in the Elsevier, and is in Springer publication. This student, she is working on how different land use, land cover are responsible in the underground pollution of Ghaziabad district of Uttar Pradesh. She is pursuing her PhD, and recently we had this publication also in Elsevier. And this student, she submitted her thesis. So she worked on seasonal black carbon emission in the urban Delhi. So these are the few publications we had on EIA studies. So similar is the case in case of faunal species. Also, we can use same technique. We studied different physical parameters of third desert of Rajasthan to find out the best site for the survival of desert monitor. 2 projects we completed. One is from DST. This is from DST, and that is from the Ministry of Environment and Forest. So this is the publication came out. So these are the areas which are the best suitable for the survival of this particular endangered species. That is the desert monitor. It had published in International Journal of Geological Research. Probably from that field they can know about this journal. Anyway, so in this way, in different fields also we can utilize this technology. So in the field of wildlife, we had some very good publication. Some 2 days back only, we had one publication that was done for the carbon sequestration in Sariska Tiger Reserve of Rajasthan. It was published in Journal of Cleaner Production. You can just browse it. This journal, it's having very big impact, almost 7.5 impact it has. Last week, 3-4 days back only, it has appeared in their website to publish it. This is again Springer Nature publication. This is also a human leopard conflict in Aravalli landscape, Haryana. It was published last month. And these 2 publications are from our own area. This is for Karbi Anglong Kaziranga Wildlife Corridor. And this study was done in the Povitra Wildlife Sanctuary of Morigaon. Okay. So how a traditional landscape can be affected by human interference. To know that, we did one study in the Siroi Hill of Manipur. The Siroi Hill is famous for the Siroi lily. Probably you are aware. That lily is very much endemic. It grows only in that particular hillock. After many efforts, even that plant could not be grown in other parts. So this area also affected by human interference, and we did this study to quantify the impact of human interference in the traditional landscape like Siroi Hill. So this is also published in very reputed journal recently. Okay, this is related to disaster. We published one paper last month, that is transport and health. Though we are from different background, we can still contribute to the society in some way. What we did, we collect data from 36 traffic corridor from Delhi, who are Delhi, and we took out the parameters that are hampering our health. By interpreting all these parameters, we could prepare the mortality map of the Delhi, total mortality map, and the vulnerable distribution map of the national capital using all these different parameters. So this work, I don't know, we got very good appreciation from the medical fraternity, and this is a unique type of work. We feel proud being a geographer, being a remote sensing and GIS analyst. We can at least contribute to the society in some way or other. Okay, now I'll coming to the remote sensing application in disaster management. Okay, so we know what is disaster and what is hazard. Hazard is simply potentially damaging phenomena. And when we call a disaster, when it occurs in densely populated areas and there is heavy destruction of life and property, and local governance cannot cope up with the situation and needs help from the external agencies, and that type of situation we call a hazard. So this is the global distribution of different hazards as I have kept it. Okay, for any disaster type, suppose this is a damage by this image is from Colombia earthquake. So this is the damage. For any type of disaster, there are characteristics of spatial characteristics. Spatial characteristics. Spatial means it relates to space where this particular phenomena occurred, distance from the source, scale of object damage, spectral, what are the materials involved in that particular damage, what's the distribution of these materials, so the tone and pattern are helping in identifying the different materials involved in the damage. Length of the event, possible repeats, delayed effects. So these are the characteristics of disaster. Again, we have already discussed in detail about the data type in remote sensing. It has spatial, spectral, and temporal characteristics. We could correlate this remotely sensed data and the characteristics of disasters. So any type of disaster, when we talk about earthquake also will have all these different characteristics. When we talk about a flood also we can have all these different type of characteristics, or any type of disaster, we have all these characteristics. But when we use remotely sensed data, there are some constraints, of course. Suitability of the disaster type we are going to study, availability of data for that particular time, cost involved, software, and the expertise, the people who are working. Of course, these are eradicating now, software and expertise. These are available comparatively, and still, though we have constraint, we go for remotely sensed data for any disaster type of studies. Okay, this is skipping it. It's taking too much time. Okay, a given disaster can lead to a number of consequences with different spatial, spectral, temporal characteristics. A building collapse, fire, landslide, dam service. These are the consequences of any type. Okay, what remotely sensed data can contribute in disaster management? Monitoring the hazard in real time, provide information on the evaluation of the event and foreseen future stages of the hazard, damage assessment, quantitative or qualitative investigation of the damage caused by an event, including effect on life and property, as well as access to the site, provide spatial information to maximize effectiveness of relief efforts, monitoring of residual hazard, and to avoid secondary disasters, and aid to the areas by the external agencies for rebuilding purposes. So these are the different stages. When we go for any disaster management, it can have different stages: pre-disaster stages like preparedness and prevention stage, then during the event, then rehabilitation, reconstruction, and relief stages. So these are the different stages. Probably everyone is aware. I'm not discussing in detail about the stages. I'll come to the remote sensing part, how remote sensing can help in different stages in disaster management. Okay, in case of remote sensing, how remote sensing can help in prevention stage. Catalog with spatial component in hazard assessment, element at risk mapping, vulnerability assessment, risk assessment, and special decision support system. Beforehand, we can have all this information like hazard assessment. We know of landslide hazard mapping, that seismic hazard summation, and so on. Beforehand, we can prepare all this with the help of remote sensing data. During preparedness, disaster plans, anomalies in time series, cyclone is generated here, after how many hours cyclone will hit the coast. So based on that, we can forecast an early warning, monitoring of an ongoing situation. Disaster relief, mapping extent of disaster, damage assessment, relief coordination, evacuation, recovery, organization of damage information, post-disaster census, identification of site for reconstruction. I have one very good case study for this. I'll be discussing that, and ultimately we can update the hazard vulnerability and the risk database. Okay, I'm just skipping this. Okay, so how we can study flood with the help of remote sensing data in different stages. In case of prevention and preparedness stage, this is an anaglyph image. That if we had a spec, then we can have a three-dimensional view of this area, but we can have DEM, digital elevation model. This model tells us about the topographical condition of the area. If we have the land use land cover map of this particular area, we can simply superimpose the land use land cover map top of the DEM. Then we can know which are the areas located in the low-lying areas, so that beforehand we can know that this much intensity of rainfall can cause havoc to these areas which are located in the low-lying areas like many parts of Morrigan district. Okay, so ongoing scenario, how we can map the inundated areas. As I have told you that only cloud will be appearing if we use the optical remote sensing, but radar help us in getting those information, and with the help of radar we can easily map the inundated areas because of the flood. So in this way, okay, this study really help us in understanding the flood scenario of our own place. This is the pre-flood image of Assam, and this is a radar image. And radar image, this all black signatures are the areas which are of inundated, flood inundated areas. So based on that, we can have a flood map for the entire state. And if we are interested for a particular district, then I can take out, for that. Here I have information about the Morrigan district. Morrigan district, I have the village map, I have the flood inundated areas that I have achieved from the radar imagery, and superimposing these two, village map and the flood inundated areas, then we can have the maroon villages against which village having how much area under flood. So this type of imagery really can help us, really can help the authorities for the management of flood disasters. So this is again for Morrigan district only, how much area under submerged, crop area under water, how much area under totally flood water, what's the crop area. So all this type of information we can have for the particular district. In that particular year, this much area was affected, crop area was submerged. Again, these are sequences of flood from 28 June to 13 July. What's the sequences of the flood inundated areas? And this can be supported by the hydrograph. In hydrograph means that the relationship between time and the water level. So in this way, we can have some scientific study. So recently we did one study in to know the flood hazard risk assessment for a proposed LPG site in Oman, Salalah, just before pandemic, lockdown. I did this study. So what we did it, we studied the catchment level first. What are the condition? That's the location of the study site, that proposed LPG site. This is a relation with the elevation. This is the drainage basin, which are the river basin. They are contributing water to the site. This is the hillset. This is the slope. This is contour. This is aspect. This is flow direction. This is curvature. This is drainage density. These are the interpretation in the catchment level. In the project site level, we have this contour interpretation. This is 1 meter contour for the project site. This is 0.5 meter contour. This helps us if there is stagnant of water after setting up of the plant. Is there any probability of draining out the water bodies? So this is slope. This is flow direction. This is flow direction. This is the elevation, and this is the site. And if there is inundation of water because of during the rainy season, then this water having the.
Sharma sir, present slide is not coming.
Is it?
Slide is not coming, sir.
Oh. Well, is it coming now? Is it coming?
Yeah, it's coming, brother.
Okay. So yeah. So if I'm taking too much time, please stop me in between. Huh? I'll take another 10 minutes. Panel analysis. Yeah, this is 1 meter contour. This is 0.5 meter. Okay, this is already discussed. So if water is inundated during the rainy season, then these are the paths where that water can be drained out. So we have the positive impact for this study, and it was really appreciated by the authority. Anyway, so I do not have many publication on flood. So we had one public from Assam. I had one publication from Orissa, that is geospatial modeling for flood management in rural development block of Orissa. So this was published in Disaster and Development Journal. Okay, earthquake. Until that, no technology is there to predict the time of the earthquake, but we can always identify the probable areas by identifying the fault line or lineaments, so that we can have the idea that how where this devastating activity can happen. Okay, suppose we have an imagery something like this, an earthquake damage is something like this. So this type of imagery is of no use, but for this, if the first one was MSS 80 meter spatial resolution, this is 30 meter spatial resolution. Here we can have little bit idea how where the damage occurred, but for this we have to have very high spatial resolution imagery like ICONOS, where each and every building can be identified. Okay, these are the imagery, ICONOS imagery of Bhuj earthquake. So by studying the tone, texture, pattern, we can identify which are the buildings not affected, which are the building completely damaged, which are the buildings partly damaged. Those are the buildings can be identified. Oh, fine. Okay, this image is from Colombia earthquake. So just okay, this is a post-earthquake imagery of Colombia. Because during my study, I was involved in this particular exercise. This is the post aerial photograph of that particular area. Here you can see many buildings are standing, many buildings are partly damaged, and many buildings which are completely damaged. So what we can do, simply we can delineate different type of buildings. Hello? Okay, after delineating all these different type of status of the buildings, we can know that these are the areas having maximum damage. In reconstruction phase, this type of interpretation really help. This is our finding, and this finding can be correlated with the existing geological map. If you superimpose the geological map with our result, then it was apparent that maximum damage occurred in those areas where there were presence of lineaments. Normally what we do, when there is destruction of buildings, again, we reconstruct the buildings in those areas. Probably after having this exercise, we will not suggest the authority to reconstruct the buildings in the areas where there is presence of lineament or fractures. Definitely buildings will be suggested to construct away from the lineaments. So in this way, okay, landslide, fine. To locate the landslide, again, high resolution satellite imagery are required. Again, we have explained it, how different physical and cultural activities like construction of road, construction of dams, they are responsible in enhancing the landslide activities. So already we discussed it. This is a high resolution imagery where we can identify different parts of a landslide, like where is the crown area, depression area, accumulation area. So this is an aerial photograph, and actual, this is the actual landslide that occurred, that we can identify it. Okay, so two publications we had. We had, what is? Two publications we had. One is from already we talked about the Tawang, that one, and another is from Meghalaya. It's Noktak Biosphere Reserve, that was on soil erosion vulnerability mapping. Okay, wildfire hazard. How wildfire hazard? Definitely, by we are confident that IR data, infrared data are used for identifying the warmer areas. So wildfire are a huge global problem. Remote sensing based fire monitoring is done routinely both at regional and global scale. Thermal infrared, AVHRR, active very high radiometric radar, MODIS, Landsat, SPOT, ICONOS. These are the satellite. They are contributing the imagery to identify the forest fires. For drought assessment, basically, we use one what is called index. It is called NDVI, Normalized Difference Vegetation Index. For drought assessment, basically, we do go for this. The coal fire hazard, already I discussed how coal fire mapping can be done. This is a study, it's an old study of during the Gulf War, how IR imagery were used to identify the ignition point during that particular year in 1991. Almost 600 oil wells were ignited. The last one was in the November 1991. So I had one publication recently in Delhi. So fire engineering, it was to fire incident mapping and risk analysis. Okay. Anyway, so oil spills, yes, it's very much apparent. This easily can be identified. Professor Biju Tapalia was talking about the oil spill. This is how we can have the oil spill mapping. Then contaminated areas mapping in and around the industry can be mapped with the help of very high spatial resolution imagery. The coastal hazard, last one. This is the last type. The coastal monitoring and damage assessment, multi-temporal observation of changes, tsunamis, coastal flooding, storm impact, beach loss, to some extent, stability of the flow. That super cyclone, probably everyone, if you remember it, 1991, that time, this technology was not that updated that time. So there, as a result of that, there were around 12 districts from Odisha, coastal district were affected and more than 10,000 people killed. And these are the statistics. So there were 2 days time in between from initiation to the impact. So people were not properly warned so that we could not save the people and property. But the recent success story is completely different. Tsunamis. Okay, real-time observation is not possible. With the help of DEM, geomorphological interpretation, we can identify which are the areas going to be affected first. The damage assessment, of course. In this way, we can identify the areas. This is the imagery of Sumatra tsunami-generated earthquake before tsunami. This is post-tsunami. Damage assessment. This is before, post. Before and after tsunamis. In 2011, that Sendai or Tohoku earthquake of Japan, there are huge devastation that Professor Biju was mentioning. This is the pre-image. This is the post-image of tsunami. Yeah, completely destroyed. So in this way, this temporal data, if we have, then it has very, very wide applicability for damage assessment because of any disaster type. So it was a real pleasure for me to be with you. Thank you very much, and I'll be happy if I can able to answer your query if you have. Thank you very much.
Okay, sir. Thank you, Dr. Sharma, sir.
And here, just I would like to take the opportunity to thank the organizer to give me this opportunity, and it was real pleasure being with you all and sharing my experiences in the field of remote sensing and in the field of disaster management. And Biju sir, it was real pleasure listening to you. It was very thought-provoking talk from your side. I thoroughly enjoyed your deliberation. Probably everyone benefited. Thank you very much, and wish you all the very best. If you have any query, you can. I'm very sorry I took more than
Thank you.
time given to me.
Okay, sir. Thank you very much. Thank you. Thank you for your valuable presentation that you have clearly discussed about the basic principle of remote sensing and details about electromagnetic spectrum, its role in remote sensing, characteristics and types of remote sensing, remote sensing in disaster management. All applications are explained with effective local example. Thank you, sir. Thank you very much. Now, our one of our former person, respected Professor Kapalia sir, has connected during presentation. So may I request Kapalia sir to within a few words, sir,
Yeah.
Kapalia sir.
Thank you. Thank you, Dr. Chakradhar Deka sir. Sorry that I got interrupted because of the net connection here. I was very unfortunate that I could not complete my presentation then. But it was really wonderful listening to Dr. Kiranmoy Sharma, and I'm sure he's such a knowledgeable person in this topic, so that he has covered most of the things. I don't have much to add now because I did that topic completely. What I say is that there is a lot of scope for remote sensing in the disaster management, and I'm sure the researchers who are here who wants to do research in the area of geography or in the area of remote sensing, disaster management could be one which you can look into to see how application of remote sensing can be done in mitigating or in planning or in preparation for disaster that may occur in the region that you are interested to do a study of. Like suppose if you are in Assam and you want to do something on that, maybe I would recommend, because already Dr. Sharma has said that, you know, with the remote sensing you can assess the point which are more vulnerable for earthquake or even for the flood. So maybe we can do from the humanitarian point of view or the disaster management point of view also, we can do some research to find what would be the catchment area where we could have our, you know, warehouses to respond quickly to the disaster area. So we can do it in those ways also. So that's what I would like to say in the end. Like there are a lot of scope for research in this area also. And I would like to encourage researchers to come in this area, remote sensing and disaster management, because this is something very, very useful for the society, especially when we are talking of the population of Assam. So I think it is very, very important to do that. Saying this, I thanks once again the organizing committee. I thank Dr. Chakradhar Deka sir. I thank the whole webinar committee, principal, and everyone, and my co-presenter today, Dr. Kiranmoy Sharma from Indraprastha University. I had a really wonderful time with you all. Thank you very much.
Thank you, sir. Thank you, Thapalia sir. Now I proceed to next agenda, interaction session. I request first Pranjal Kumar Hazarika of our college to select few questions. And next I request Dr. Vijay Kumar, IQAC coordinator, to select only few questions. Okay, over to Hazarika.
Thank you, Dr. Chakradhar sir. Some queries regarding the first presentation by Thapalia sir has come, and I have noted down 3 queries. Am I audible?
Yes, please go ahead, sir.
One query has come from Kamal Khatra from Jawaharlal Nehru College, Punjab. The query is that how we can overcome natural disaster. Is it possible, and what measures should we adopt to overcome such kind of natural disaster that usually we meet?
Well, should I take it now or should I wait for all the questions?
As you wish, sir.
Okay, fine. I take this question then. Thank you very much, Kamal Khatra sir, for your question. I know that this is a very interesting area. So whenever we are using this disaster management, we always want to mitigate it. We always want to have a pre-warning for it. And I'm sure remote sensing can do a lot in this. So there are a lot of ways in which we can utilize the remote sensing for, we can't say avoiding, but at least minimizing the impact of the natural disaster that may happen. Okay, so that we can do. As basically, I just recently in this area I read that there's an organization or a volunteer organization from different association of different organization, which is led by Microsoft in the US, which is called 5 Minute organization. That means, just within the 5 minutes of disaster, what are the things that can be done to minimize the impact of that disaster? And there, the most important thing is that remote sensing data that comes, and the main thing is that we need to integrate. There are a lot of data that are there, but these are not to the people who need those for taking that step. So that's why this organization is helping to come all the different organizations to make this response very quick, so that the impact is very, very minimum. Okay, so I hope there will be a lot of studies, and researchers are welcome to do more studies to utilize remote sensing for minimizing the risk in the natural disaster. I will answer in that way only right now. Sir.
Hello, sir. I think Kamal Khatra was satisfied with the answer of Thapolia, sir. I think. Another query. Am I audible, sir?
Yes, yes.
Another query has come from another faculty member of Bhattadev University, Assam, Satyajit Das. Actually, Mr. Das is asking whether the application of remote sensing technology is very much effective in overcoming the flood and erosion problem, especially in Assam. And under queries linked with that particular query is that regarding the artificial flood of Guwahati University, is it possible by using the application of remote sensing that we can solve the problem of artificial flood in Guwahati city? These are the queries.
Okay, thank you, Das, for your wonderful questions. Basically, remote sensing will definitely be helpful in predicting the areas which will be in high risk when there is a flood in Assam. So those can be identified, and preparedness team can be created accordingly. One thing. So another thing is that I'm sure there are a lot of studies which has been done. Maybe Dr. Sharma will be able to inform, because I may not have been able to look into those research which has been done, especially focusing in Assam. So regarding the flood, utilizing the remote sensing and its preparedness and its response. So maybe there are many, I'm sure it's done. And regarding the flood that you have been referring to, because I was just looking into the presentation of Dr. Sharma, and then, he was giving an example of this site where suppose they are planning to make, I think it was in Oman or something, some place where, they will look into the topology to see where the water, if water is there, then how, in which direction it will flow out. So maybe those kind of study can be done in even that what university area that has been mentioned here in this question, to see which topography, where the the exit point can be created, so that those flooding can be deflooded very quickly. So maybe those things. I'm just bringing this to the recent presentation, that knowledge that I got from. So maybe that can be utilized using the geo sensing or remote sensing information. Hopefully, maybe Dr. Sharma may be able to respond to it in a better way in this. Thank you.
Okay. Okay. Should I add here? Or?
Yeah, Sharma sir, please. I think it will be wonderful.
And you have already explained it. Whatever I was thinking, you have already mentioned those points. So what I could understand regarding the flood of Assam, he was talking. The first part was how we can mitigate the flood of Assam. So what remote sensing can contribute? Already I have mentioned there, like mapping part, of course, sequential flood inundated areas. So those are the interpretation, probably with the help of hydrographs and all. Probably we can have very good scientific input for the flood sequences of flood, and which are the areas are more recurringly affected because of the flood. And regarding Guwahati flood, probably everyone is aware that natural drainage system is disappeared now. So, as a suggestion of layman, what I can say, the revival of wetlands probably is a good solution. So, water cannot drain out actually, though we have very uncomparable water resources like Brahmaputra, but it is not properly utilized. So, whatever water we have to be accumulated, those wetlands are now encroached, everyone is aware. If we can revive few of the wetlands, probably those drainages which are blocked, once it is cleaned, probably those water can be stored in the wetlands, because wetlands are considered as a kidney of the society. So once the wetlands are removed, means we have to face this type of problem. Probably a civil engineer can have better solution for this, but being a GIS or being a remote sensing analyst, we can suggest that those things could be our contribution in this particular aspect. Thank you.
Okay.
Thank you, sir. Next, I would like to request Dr. Vijay Kumar Nath. If you have some queries that came to you, you just mention it to the Sharma sir.
Thank you. Am I audible, Dr. Dega
Yes,
sir?
sir. Yes, sir.
You can,
Yes, sir. Thanks to Dr. Sokodar Dega for giving me the chance for interaction. Now there are 4 questions from 4 participants. Shweta Chaudhary, Neeraj Sharma, Baharuddin Laskar, and Kamal Khatra. And due to shortage of time, I would like to request Dr. Sharma sir, only one question, which I think very important or relevant one, from Shweta Chaudhary. With the question is, how can we best utilize remote sensing for disaster mitigation and disaster risk reduction? So thank you, sir.
Thank you for the query. Probably I covered most of the contents for these questions in my presentation. I'm extremely sorry I could not follow the pace. I was a bit fast because of the time constraint. In all my case studies, I covered in the risk, rightly Biju sir has said, like that for flood one, how we can assess the risk because of the flood. That Oman example, and that Tawang example, probably we can identify the areas which are going to be affected if the construction of dam will be implemented. So there are proposal for micro hydroelectricity power plant in Tawang district. All of us, we know about the Gerukamu, the large dam. But just to overcome from this type of problems, MOEF, they have initiated for the micro watershed, and those are the few examples for this. And probably there are many aspects in that particular study. Around 36 organizations were involved, and my portion was to identify the vulnerability in case of landslide and in case of soil erosion. So these 2 aspects I covered in that particular study, and risk generated once these are constructed in these 2 aspects, which are the area going to be affected most. So in this way, probably we can identify it accordingly, best suitable measures to check from landslide and soil erosion vulnerability can be mitigated. So yeah, and I'll be happy. I mean, my email ID is already there in the presentation. I'll be happy if I can be of use sometimes for whatever I know. I'll be happy to share my experiences in Yeah, thank you.
Thank you, sir. Now over to Dr. Deka sir. Deka sir, please.
okay. Thank you very much, Dr. Vijay Kumar Nath sir. Now I will request Madam Chatterjee, Principal, Chorabari College. coordinator. Kakoti sir, they are audible.
Hello. Yes.
Kakoti sir,
Yes.
okay. You can few words.
Hello.
Kakoti sir, you can proceed, sir.
Yes. Audible. Am I audible?
Yes, you
Yes,
can
yes.
proceed, sir.
Hello.
You can proceed,
Yes.
sir. Yes, sir, you can proceed.
Yes. Am I audible?
Okay, you can
Yes,
proceed.
yes, you are audible.
Yes. Thank you. Respected Principal of Sarvahi College.
Please, class chalaइए
On behalf of
Kakoti sir,
Kakoti
your voice
sir,
is not audible.
sir, your voice is not coming. You are not audible, sir.
I heartily thank the organizing committee, especially the principal of Sarvahi College and the coordinator of international webinar, Dr. Sokotho Deka, and the head of the Department of Political Science, Mr. V.S. Kumar Deka. I hope our participants are immensely benefited from the webinar. Now, I would like to conclude my speech without wasting much of your valuable time. Thank you. Over
you,
to
sir.
Dr. Sokotho Deka.
Thank you, sir.
Thank you,
Thank you. Now,
Thank
now I
you.
request
Thank you.
V.S. Kumar, sir, HOD Political Science, to give vote of thanks. V.S. Kumar Deka,
Yes,
sir.
thank
Yeah.
you. Thank you. Thank you, Sokotho Deka sir. Am I audible?
Okay,
Yes,
you
yes.
can proceed.
Respected chairperson, inaugurator of this international webinar, Principal Sarabhi College, Dr. Kamal Chandra Nath sir, Honorable Research Person, Professor Dr. Biju Kumar Thapalia sir, Dean, Faculty of Management, Purvachand University, Nepal, and another Honorable Research Person, Dr. Kiranmoy Sharma, Associate Professor, GGS, Indraprastha University, Delhi, Vice Principal Madhuram Kakoti sir, IQC Coordinator Dr. Vijay Kumar Nath, and members of the IQC, Coordinator Dr. Sokotho Deka, Organizing Committee, colleagues, students, and participants from different parts of the country in the world. Myself, V.S. Kumar Deka, Head of the Department Political Science. As part of our agenda, it is my privilege to have been asked to propose vote of thanks on this occasion. At the outset, on behalf of the organizing committee, I offer my vote of thanks, Principal Sarayapuri College, Dr. Kamal Chandra Nath sir, inaugurator of this international webinar, and for giving us permission to arrange this international webinar and for enthusiastic support. Thank you, sir. I, on behalf of the organizing committee, extend a very vote of thanks to the Honorable Research Person, Professor Dr. Biju Kumar Thapalia sir, Dean, Faculty Management, Provincial University in Nepal, who blessed us with his presence and took out a valuable time of the busy schedule and gave us positive statements, ideas, and thoughts. Thank you so much, sir. I would like to sincere gratitude to another Honorable Research Person, Dr. Kiranmoy Sharma sir, Associate Professor, GGS Indraprastha University, Delhi. A very, very big thanks, sir, to all gracing your important work and sharing with us your findings and your today this international webinar. Thank you very much, sir. I would like to offer my vote of thanks to Principal Madhuram Kapoti sir for his important and providing encouragement support to end this international webinar. Thank you, sir. I offer my vote of thanks to IQAC Coordinator Dr. Vijay Kumar Nath and members of the IQAC Sarayapuri College, inspiring us for ending this webinar. Now I offer my vote of thanks to Dr. Sakadhar Deka, coordinator of this international webinar. It is for his continuous support to help that make it easy to organize it international webinar. I would like to convey my heartfelt thanks to members of the organizing committee and teaching staff of Sarayapuri College who have directly and indirectly contributed for arrange this international webinar. And lastly, on behalf of the organizing committee, I collectively offer my vote of thanks to all the participants and students from different parts of the country in the world for joining us in this virtual platform and interact the topic to making this webinar grand success. With this one words, a kind message, I move to in full of thanks to this international webinar. Thank you, sir. Abhay, Dr. Sakadhar Deka.
Thank you, Deka sir. Thank you very much. Now I go to last part of the webinar. This remarkable, memorable, and knowledgeable event that is on the international webinar. On behalf of the Sarayapuri College, I would like to thank once again Professor Biju Kumar Thapalia sir and Dr. Kiranmoy Sharma sir. I also thank all the participants of working in this international webinar. I hope the topic of the webinar is so relevant for present day situation and hope presentation of our honorable research will give some more useful ideas and knowledge in our mind. See you in the next webinar in our college. Thank you. Thank you to all once again. Take care, stay home, stay safe. Now end the session. Thank you very much.
Thank you. Okay.
Thank you, Sakadhar.
Thank you, Sakadhar sir. Thank you, Kiranmoy Sharma sir.
Thank you.
Thank you very much.
Thanks to all.
Nice listening to you, sir. Thank you, Sakadhar, for organizing wonderful
Thank you so
program.
much. Thank you so much.
This is Mark Khattar from Punjab. Thanks to all the organizers, sir. Thanks a lot.
Principal sir, Kamal sir, and thank you very
Thank
much.
you. Thank you. Namaskar.
Wonderful
Namaskar. Namaskar.
মই অসমতে মই অসমৰ হয় ওদালগুৰি মই অসমৰ হয়
লগ পাম ফিজিক্যালি লগ পাম স্যার নিশ্চয়
চিয়ৰ ইয়াত আহি পচি গৈছো দিল্লী দাই
থ্যাংক ইউ স্যার থ্যাংক ইউ ওকে বাই বাই
মই এতিয়া ইয়াৰ পৰা বাই কৰিছো
লগ পাম থ্যাংক ইউ ভেৰি মাচ
বাই
বাই
বাই